Good morning and once again welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And I want to explain example 3 of graph 8, and we are told that the area of weed covering part of a pond doubles every 10 years. The area now covered is 100 meters square now at 0 time. So we are at 0 time, A. Given that the area of weed, A meters squared after n years, is given by 100 times 2 raised to power 0.1 n, draw the graph of A against n, the graph of A against n years, draw the graph of A against n for n between 0 to 40. Let us do that. Of course, we know A is given by 100 times 2 raised to power 0.1 n. And there we are. Let us talk about that. As when n is 0, of course, we are talking about doubling every 10 years. Substitute 0 here. 100 times 2 raised to power 0, meaning times 1, we have 100. And we are told clearly that the area now covered is 100. So when time is 0, then we have 100 meters squared. What about when we have 10? 10, n is 10. 0.1 times 10 is actually 1. 0.1 times 10 is actually 1. So 2 raised to power 1 is 2, then times 100 is 200. And we are told that the area of weed covering part of a pond doubles every 10 years. So after every 10 years, we are doubling the area. So no wonder when we are talking about n being 0, the area is 100. After 10 years, the area doubles. So that means after 20 years, you either substitute in the formula or you use this statement. The area doubles after every 10 years. So from 10 to 20, that is a double. The area should be 400, the double of 200. After another 10 years, 30, we have 800. And another 10 years, 40, we have 1,600 as our area. And that is it. So given that the area of weed is A meter squared after n years. This is A and this is n. This is our area, meters squared, and this is our n in years. And the area doubles after every 10 years. So we are saying at 0, we have 100. At 10 years, we have 200. After 20 years, we have 400. After 30 years, we have 800. And after 40 years, we have 1,600. There we are. And what we are having is a very good curve. Very good curve. That way. And we can also call it A is equals to 100 times 2 raised to power 0.1 n. That can be the name of the graph. Now, answering the question. We have actually drawn our graph. Part B of the question, by drawing suitable tangents, yes, find the rate of growth of weed in meters squared per year after 10 years. So you can already see after 10 years, that is the gradient is not the gradient, but the tangent is going to be drawn that way. Tangent, let us draw this tangent. And let us just have our triangle this way. We have 380. This is the 300 and this is like 80. So we have 220. That is the rise. That is the what? That is the rise. That is So what is now the run? What is the run? The run, we can see this is like 0, this is 2.5, this is 5, 7.5, this is, let's say, 2.5, and this is 10, 12.5, 15, 17.5. This is 17.5 or thereabout. This is 17.5. So at n is equals to 10, then we have the rise, which is 220 all over 17.5 minus 2.5, which is basically 15. And let us see. 220 divided by 15. We realize that we are talking about 14.7. So the rate is 14.7 meters squared per watt per every per year. Per every year. That is the rate of the growth of the weed. Because remember, we have talked about constructing a very good tangent and establishing the rise, which is 300 minus 80, giving us 220, and the run 2.5 all the way to 17.5 here. 17.5 minus 2.5 is 15, and we are getting the rate at that particular point as 14.7 meters squared per year. The question continues to ask us to get the rate of growth of the weed in meters squared per year after 30 years. So after 30 years, meaning after 30 years here, we need to construct a very good tangent now here. Let us have a very, very good tangent, and let's have that way. And that way we can talk about the rise and the run. This is 90 degrees. And we can only establish that and have, this is 400 and this is 1200. 1200 minus 400, that is 800. Rise. You can already see 1200 if you walk along that line, minus 400, it is 800. What about this? This minus this. So this is 22.5. This is 22.5, as you can see. And this is what? 32.5, 35, 37. This is 37.5. So 37.5 minus 22.5, let us see. 37.5 minus 22.5, we have 15. So at n is equals to 30, we have the rate of growth of the weed equals to the rise, which is 800 out of all over 15. Let us see what is this. 800 divided by 15, we are going to get 53.3. 53.3 meters squared per year. Per year. That is something to do with something just to do with what we have understood, or we can talk of yeah, that is it. That is just it. So we are going to realize that the gradient at x or at n is equals to 30 is of course bigger or higher than the gradient at n is equals to 2. So the weed continues to grow faster because you can see the gradient is higher now, and that is exactly, we may not really be able to get exactly what we would have gotten or we would have expected, but that is it. The aspect and the skill of coming up with a tangent, talking about rise over run, that is exactly what we would want to teach in this particular question. So there you go. That is example 3. Kindly subscribe and let us meet in the next video.